Good day viewers, welcome back to my channel. Today we have the following interesting limit problem, which is read as follows. Limit as x is approaching to x raised power 4 minus 16 all over 4 minus x raised power 2 equals dash. Please, if today is your first day of visiting this my channel, please subscribe to this channel. Thank you. Now let us make direct substitution first. Let us see whether we get something meaningful. Okay, if we make direct substitution, we know that 2 raised to power 4 minus 16 all over, that's what we have, 4 minus 2 raised to power 2. And if you check properly, 2 raised to power 4 is 16, 16 minus 16 is 0, all over 2 raised to power 2 is 4, 4 minus 4 is 0. And this is not allowed in mathematics, okay? This is in indeterminate form. Okay, wow. In this solution, I'll be presenting two different methods. The first one is the L'Hopital's rule, okay? So the first one is the L'Hopital's rule. So what does it mean? So let's see what this rule is telling us. When we have limit as x is approaching a of a function f of x over another different function g of x, so this is the same as limit as x is approaching a of d the x of f of x, so that is differentiating f of x all over d the x of g of x with respect to x. So this is what the rule is all about, okay? Now in our limit as x is approaching to of x raised to power 4 minus 16 all over 4 minus x squared. Okay. Now let's call f of x to be equal to x raised to power 4 minus 16 and g of x to be equal to 4 minus x raised to power 2. We can see that f prime of x, just differentiating this, so is 4x raised to power 2, and g prime of x is equal to negative 2x. Okay, so we have our limit to be the same as limit as s is approaching to. So after differentiating this, we got 4x cubed all over. After differentiating the below one, we got negative 2x. This is equal to, the constants out, 4 all over negative 2 limit as x is approaching 2 of x raised to power 3 all over x. So we know what this is reducing to. So from here we get negative 2 limit as x is approaching 2 of, reducing that to x raised to power 2. So from here inserting the limit, so we get negative 2 times 2 raised to power 2, and this is equal to negative 2 times 4, and this is equal to negative 8. So we obtain the first solution using the L'Hopital's rule. Okay, now second method, let me attach it here. Second method, we're going to make some algebraic manipulations here, considering the functions x raised to power 4 minus 16 all over 4 minus x raised to power 2. I believe we'll be very familiar with the difference of two formulas, difference of two squares formulas. That is, a squared minus b squared is the same as a plus b times a minus b. Okay, so x raised to power 4 minus 16 is the same as x raised to power 2 raised to power 2 minus 4 raised to power 2, and this is equal to x squared minus 4 times x squared plus 4. Okay, so this is the same as, x raised to power 2 minus 4 times x raised to power 2 plus 4 all over 4 minus x raised to power 2. We're about to do cancellation, like eliminating this denominator here. But how can we do that? Remember that here we have s squared minus 4 and we get here 4 minus s squared. I was even trying to make big cancel this out, but they are not the same. Okay, so only the way the number that is the constant, the positions make them different. Okay, see what we're going to do here. I have here x squared minus 4, x squared plus 4 all over. So I'm going to factor out a negative sign. Minus open bracket, then I get x squared minus 4. Okay, so I think this makes sense. So this makes very sense here, right? So here we get this cancelled out. So we get negative open bracket x squared plus 4. Okay, so wow, our limit now as x is approaching 2 of x raised to power 4 minus 16 all over 4 minus x raised to power 2 is the same as negative limit as x is approaching 2 of x squared plus 4. So inserting the limit, so we get here negative 2 in bracket 2 squared plus 4, and this is equal to negative 8. So we use the second method to obtain the same result. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting and exciting videos. Thank you.